Hi everyone, this is example 16 on unsteady flow. A reservoir of land area 34.6 hectares is controlled by a weir with permanent crest elevation of 124 meters. The crest of the length of the crest is 4 meters and the water surface is at elevation 125 meters. So meaning the initial head is 125 minus 124, so 1 meter. Determine the time it will take to draw the water surface down by 100 mm or zero point 0.1 meter in minutes for the following situations. A rectangular weir is used with coefficient of discharge 0.62. A Cipolletti weir is used and a 90-degree V-nuts weir is used. So formula for the time is integral of area SDH from HF to HI over Q out, and Q out is Q of the weir, whichever weir it is used in this problem. So if it is rectangular, then we use rectangular formula for discharge over a rectangular weir, which is 2.953 CL H to the 3 halves. So we use small h because h is variable here. The limits would be the initial head is 1 if the water surface mass lower by 0.1 meter, so the final head should be 0.9. Area S is constant at 34.6 times 10,000 square meters per hectare, so that would be 346,000. So time is integral from 0.9 to 1 of 346,000 dH over 2.953 times 0.62 times 4 h to the 3 halves, and this 60 here is introduced to convert the time to minutes because the requirement is time must be in minutes. So computing for the constants, remember the integral of dh over h to the 3 halves is negative 2h to the negative 1 half with our experience. So negative 2h to the negative 1 half from 0.9 to 1. So time is equal to 787.426 times negative 2. H to the negative 1 half is the same as 1 over square root of 8. So 1 over square root of upper limit minus 1 over square root of lower limit. So we can now compute for the time in minutes, 85.19 minutes. For the Cipolletti weir, same exponent of the variable. So same integral except for the constant. So time is integral from HF to HI of area S 346,000 dH. Formula for Cipolletti weir is 1.859. L is 4 meters length of crest. Then h to the 3 halves. Then again introduce 60 to convert the time to minutes. So the constant is 775.507 times negative 2, 1 over square root of upper limit minus 1 over square root of lower limit. So the time is 83.90 minutes. Then, of course, they are close because this is Cipolletti, where the crest is 4 meters also, the length of the crest, then plus the angle with the vertical, so this is bigger. So it will take shorter time. But a 90-degree V-nuts weir, it will take long time because it is a V-nuts weir. The apex is on the bottom. There's no length there. So the formula for discharge over a 90-degree V-nuts weir is 1.4 head to the 5 halves. So time therefore is integral from 0.9 to 1 of 346,000 dH over 1.4 h to the 5 halves. Then introduce another constant 60 to convert it to minutes. So 4,119.048, that's the constant. The integral of dh over h to the 5 halves is integral of h to the negative 5 halves dh, which is h to the negative 3 halves over negative 3 halves, and the reciprocal of negative 3 halves is negative 2/3. That's why the integral is negative 2/3 h to the negative 3 halves from 0.9 to 1. So it would be negative 2746.032 times 1 over h to the 3 halves, or 1 over 1 to the 1.5 minus 1 over 0.9 to the 1.5. So solving for that time, it is equal to 470.2 minutes. So that's it for this problem.